Good morning, everyone. In today's class, we are going to be addressing solubility and how to read a solubility graph. So, as everyone can see, this is the second page of yesterday's notes talking about solutions. So, let me just go ahead and just set everything up. So, first of all, it says solubility trends. It says solubility describes whether or not a solute will dissolve in a solvent. And that's what we talked about in yesterday's class. Remember that likes dissolve likes. So what that really means is if I have an ionic compound, then or a polar compound, then an ionic polar compound will be what I use for my solvent. The universal solvent is going to be water. So most of the time we are just using water. All right, so what I'd like to do is show you a graph and just kind of explain it. I guess the big thing about this graph is that there's just a lot of information on it. Look at all the lines. So each one of these lines is a different set of solubility data. But all of them are telling us the solubility of all of these different salts. So the hardest part is just simply looking at it and figuring out, which line are they addressing. So we still have a y-axis and we still have the x-axis. On this particular graph, we are going to have temperature versus the amount in grams. How many grams is going to be dissolved? All right, so it says, what is the solubility of KCl at 70 degrees in 100 grams of water? So the 100 grams of water is what our y-axis is measured in. So let's turn over and let's look. Here we said 70 degrees, so that's going to be this line right there. We're going to follow that line up until it crosses the KCl line. So there's the KClO3, there's the Na, NaCl, and then right here at this point is going to be the KCl. So now I'm going to drop back and see where that crosses my x-axis. Now, you're not going to be able to get the exact values just because it's kind of a smaller scale. But if you look, you're going to see that we're measuring 40, then it's measuring 50. So 45 would be right in the middle, and then it's probably going to be somewhere around, and I'd say 48, and over here it is grams. So what is the solubility of the KCl at 70 degrees? 48 grams per 100 grams of water. All right, number 2 says, what happens to the solubility of the KNO3 as the temperature increases? So I look at the KNO3 and I found it right here. What happens to it? You can see how steep it's going up. It definitely increases. So that one is going to be increases. All right, what happens to the solubility of the Ce2SO4, the cesium sulfate? So cesium sulfate's down here, and it does kind of start leveling out, but we're looking at the first part of it. What is happening at the beginning of this graph? And it is going to be decreasing. All right, so we got increase on that one going up and decrease on the one going down. Which salt is the most soluble at 500 degrees Celsius? That should be 100. I apologize, that's just a little typo. Our scale is 100. So we look at that and we have to say which one is going to have the most in it at 100 degrees Celsius. So I come back over here at 100. The top is going to be right here. That one is going to be the most. So we're going to say K2, Cr2O7, and that is potassium dichromate. All right, last question, number 5. It says, which salt is least soluble as we have an increase in temperature? So least soluble, guys, is going to be the one that has the least change in its slope. So if I look at this line right here, you can see that it's not perfectly flat. It does increase a little bit, but not a whole lot. So when I look at that particular compound, it is NaCl. And that is going to be those 3 questions. All right, the next thing that I would like to do is I still would like to be using the same graph, but I want to answer the 3 questions at the bottom. So I'm going to put this one right here, and maybe I can get this to go all the way to the questions. It's going to be close. Okay, I think we can squeeze that. There we go. All right. So, guys, I'm going to come back over here and I'm reading this last set. If you remember in yesterday's class, we covered the saturated, unsaturated, and supersaturated. So I'm going to go ahead and it says refer to the solubility curve. That's the one we've been using. It says how many grams of NaCl are needed to make a saturated solution at 90 degrees Celsius. So the temperature's down here. I'm going to go up until I hit the NaCl line, which is right there. And then I'm going to go across. And I would say, 39 or 40. This graph is not real precise, so any of those would be just fine. As long as you didn't say, oh, it's 41 or 42. It's definitely under the line or right at the line. What type of solution is made when 25 grams of KClO is added to 100 grams at 70 degrees? So right here is 70. Then it says I'm going to add it to the KClO and I'm going to add 25. Well, you see right there is 25. So did I make it all the way to its solubility line? No, a little bit short. Its solubility line is like 30. So therefore, I am going to have an unsaturated solution. You say, well, how did you know that? Well, my graph is telling me that it will hold 30, and I only put 25 in there. So how much more would it hold? Yeah, you're right. It would hold 5 more grams. All right, that wasn't the question. We're going to go ahead and finish up the last one. It says, what type of solution is made when you have 25 grams of KClO3 added to a 100 gram sample of water at 50 degrees? So this time I'm going to come over here to 50. I'm going to go up. KClO's right there. But we said 25 grams, so we're actually up here. Now, I always get people to jump at the wrong answer. You say, oh, you put more in it that it'll hold. You have a supersaturated. No, you didn't. The only time you can have a supersaturated is if you make a saturated solution, then you heat that saturated solution, then you add more solid. We didn't do any of that in that question. It just said you just put in 25 grams. So what's going to happen is its solubility at 50 is about 18 grams. So therefore, the other 7 grams-ish is going to settle to the bottom. We call that precipitate. And it'd be about 7 grams settling to the bottom. All right, I hope that this has helped you. And what we're going to do next is we're going to go through and look at a graph and just go through some questions and use this same information and try to answer them on our own. All right, hope that helped.